So the objectives for today's lecture is for you guys to be able to manipulate the density equation and to solve for any of the variables found therein. And additionally, the second goal is for you guys to be able to convert between Celsius and Kelvin temperature scales. So let's go ahead and start with the density equation. The density equation here on the left is what we're going to be utilizing for all of our calculations pertaining to density. So density equals mass divided by volume, or M divided by V. So density equals mass over volume. Okay? So whenever we're looking at the density of an object, what we are having to look at is the measurement of the mass of the object as well as the volume of that object. Okay? And those two separate measurements are expressed usually in either one of two options, either in grams per milliliter. Okay, so grams corresponds to the mass, right? We know we get that from our scale. Okay, and milliliters would come from maybe a graduated cylinder. It might also come from, you know, a burette or some sort of instrument in lab that allows us to measure our volume. Okay. Additionally, another common way to see or to observe the units is also grams per centimeters cubed. Okay, so in this case, centimeters cubed is a cubic measurement. We've taken our length times width times height, right? Okay, and in this case, it's given us centimeters cubed. Now, 1 milliliter of, say, water, right, is going to be the equivalent of 1 centimeter cubed of water. Okay, and it just works out very nicely like that. So you can see the units for density being either in grams per milliliter or grams per centimeter cubed. Another thing we need to understand about density is that it's an intrinsic property. So what that means is that basically it's inherent to the substance. So for instance, like aluminum, okay, which is represented by the symbol Al from the periodic table, its density is always going to be 2.70 grams per centimeter cubed. Okay, or we could express this as 2.70 grams per milliliter. Okay, those are both acceptable density expressions. And obviously, whether the volume measurement that you're using is going to be dictated by the types of measurements or the types of equipment that you are utilizing in order to calculate your volume. Another example of a specific density that's intrinsic to that element. Copper's another example. Copper's density is 8.96 grams per centimeter cubed. Okay, or we could also write this as grams per milliliter in terms of our units. So basically density is just the relationship between mass and volume of a specific substance. And the cool thing about that is since it's an intrinsic property, you can identify the type of substance that you have. Let's say you have a couple of unknown metals. You can do calculations, you can do experiments to help you figure out what that unknown's identity actually is based on a comparison to the known density values. Okay, so let's go ahead and let's look at the density equation and how we need to manipulate the equation and do calculations for our unit. So let's go ahead and apply the density equation to some specific questions. Okay, so basically in this problem they've asked us to calculate the density of an object that has a mass of 2.2 grams and a volume of 23 milliliters. Okay, so we know that we're calculating our density, so we know we're going to be using the density equals mass over volume equation. Okay, and we've also been provided with some additional information. Okay, they have given us our mass, okay, of the object, so they've given us 2.2 grams. They've also given us the volume of the object with 23 milliliters. Okay, and they've asked us to solve for the object's density. Okay, so that's our unknown. Okay, so once we have established our variables, okay, and what it is that we know and what it is that we are trying to solve for, we then look over at the equation and figure out if any equation manipulation is needed or if we can just use it as is. Okay, so in this situation, guys, they're wanting us to solve for density. So density has already been isolated all by itself on the left-hand side. So all we need to do is plug in our variables. Okay, so density is going to be equal to the mass, which is 2.2, so 2.2 grams, divided by 23 milliliters. Okay, if we plug that into our calculators, that is going to give us 0.09565. Okay, in terms of our numerical values. Now, we need to do two things. We need to check our sig figs, as always, okay, and we also need to do a unit evaluation. So in this case, I have grams divided by milliliters. Neither of these cancel, so the units that you're going to end up with are grams per milliliter, okay, which makes sense because we've talked about our options for our density units, or our prototypical density units that we will commonly see. Okay, so in this case, we know our units are going to be in grams per milliliter, and then we need to do a sig fig check. Okay, so based on the numbers that we have that were measured, we have 2 sig figs in this one and 2 sig figs in that one. Okay, so since 2 sig figs is the lowest amount, we need to find 2 sig figs into this answer. Okay, so in this case, the second significant figure is this 5 that I just put that indicator over. Okay, so when we do our rounding, we're going to end up with 0.096 grams per milliliter as our final answer. Okay, so this is a very basic density calculation, and you would just plug in your units of mass, your units of volume, solve, check your units, of course, check your significant figures, and obviously calculate your final answer. So once we've done this, guys, we should be able to solve any density problem that could be presented to you. Now, we also need to look at situations in which maybe density is given, but maybe mass or volume are unknown. Okay, and we're going to look at an example of how to approach those types of problems. Okay, so if we look at this problem here, it tells us that we have an object that has a mass of 225 grams, okay, and a density of 444.1 grams per centimeter cubed. And they want us to solve for the volume in milliliters. Okay, so once again, guys, we want to first write out what we've been given. Okay, we've been given mass of 225 grams. Okay, we've been given a density of 444.1 grams per centimeter cubed. Okay, and volume is the thing that we are solving for. So notice in this case, guys, the density equals mass over volume equation is going to need to be manipulated to solve for the variable that we're actually looking to solve for. So I want you guys to make sure that you are manipulating the equation before you plug any numbers in. Okay, so in this case, guys, another way to look at this equation is that density divided by 1 is equal to mass over volume, right? Okay, because anything divided by 1 is still itself, right? And then what you guys are going to do is, in order to get rid of volume on the bottom and subsequently be able to get it by itself, we're going to cross multiply, okay? And this is going to give us dV equals m. Okay, now notice, I have now isolated m all by itself. Okay, but I don't want m by itself. I want v by itself. So, in order to get v all by itself, I need to basically do the opposite of whatever math is going on in this location. So multiplication is occurring here, so I need to divide by what it is that I want to remove. So density in this case is the thing I want to remove. So I'm going to divide out by density. If I do that to one side of the equation, I have to do it to the other. So my final equation is going to be volume is equal to mass over density. Okay, so I want you guys to do these manipulations before you do your calculations and do your plug-in of your numbers, because there's less likely to be errors when you're just moving variables instead of accidentally, transposing numbers or maybe writing the incorrect number when you plug it in. Okay, so let's go ahead and approach the problem and actually plug in our variables. So volume is equal to mass, which is 225 grams, divided by my density, which is 444.1 grams per centimeter cubed. Okay, so when we plug this into our calculators, that is going to give us 0.5066 4 in terms of our numerical answer from our calculator. Okay, as always, guys, we need to do a sig fig check as well as a unit evaluation. So I'm first going to talk about the sig fig check just so we can basically simplify what we have here. So I have 3 sig figs on the top. I'm doing division. Okay, 4 sig figs on the bottom. So 3 sig figs is what we're going to be using in our final answer. So the third significant digit here is this first 6. Okay, so 0.507 is going to be the numerical portion of our answer. Okay, now obviously we need to have units, so we have an appropriate quantity. Okay, so let's go ahead and let's analyze the units here. Notice, guys, I am dividing grams by grams per centimeter cubed. Okay, so basically a way to look at this is that we have grams on top and then grams divided by centimeters cubed on the bottom. Okay, now remember, anytime you divide by a number, it's the same as multiplying by the reciprocal. Okay, so if I bring this over here, okay, grams times the reciprocal is going to be centimeter cubed over grams. Okay, so what ends up happening is grams and grams cancel. Centimeters cubed is what you have left over. And remember, this centimeters cubed is a cubic measurement, so it is a volumetric measurement. So we have solved for our volume. However, guys, they've also asked us to solve for our volume in milliliter units, okay? And we talked about earlier how 1 centimeter cubed is equal to 1 milliliter, okay? And since we have that conversion factor, we can take our 0.507 centimeters cubed, okay? And we can subsequently use this conversion factor here. We know this relationship. Centimeters cubed cancel. Okay, so we end up with 0.507 milliliters as our final answer. Okay, so guys, in this situation, obviously, it was a little bit more complicated than the last example, but notice we're still kind of following similar pattern. First thing we're doing is we're writing out our variables that we know as well as what we're solving for. Okay, keeping everything organized. We're then taking our density equals mass over volume equation and manipulating it to solve for the variable that you need. Okay, so you need to get this all by itself. This is all your algebra stuff that you guys have been using for the past little bit in terms of your math education. Okay, then we plug in our numbers after we've manipulated the equations, including the units. Okay, we do a sig fig analysis and appropriate rounding. Okay, and then, of course, we do our unit evaluations. In this case, it's grams divided by grams per centimeter cubed. Dividing by something is the same as multiplying by its reciprocal, which is what we have shown right here. Okay, we do a unit evaluation there. Grams and grams cancel. Centimeters cubed are left over. That is our volumetric measurement that we desire. However, the unit of volume that they want is the milliliter. 1 centimeter cubed is equal to 1 milliliter. That's something you guys just need to memorize and have in your memory banks. Okay, we show that conversion here and subsequently get our answer in milliliters. Okay, so the same approach would be true if we were, say, solving for mass. We would do the manipulation, get the mass value all by itself, and plug in and do our calculations. Okay, so the next thing we need to look at is basically how we're going to interconvert between centigrade, scale of measurement, temperature measurement, and Kelvin. So remember, Kelvin is your metric standard. Okay, it's the standard base unit for the metric system. However, a lot of times, guys, we're going to be using Celsius thermometers to measure our temperatures in a laboratory and things of that sort. So you need to be able to interconvert between Kelvin and Celsius. And the nice thing about this is that Kelvin and Celsius are super easy to convert between. The conversion factor between Celsius and Kelvin is 273.15. Okay, so if I know my temperature in Celsius and I want to get into Kelvin, I am going to add 273.15 to the temperature in Celsius. That will then give me my temperature in Kelvin. Additionally, guys, if I want to convert into Celsius from Kelvin, I need to subtract out the 273.15. Okay, so very simple. Now, the other thing I want to mention here, guys, is that the digits to the right of the decimal, since we are doing subtraction and addition here, are going to be determined by the temperature that you have measured. Okay, so the 273.15, obviously they could express that to way more digits past the decimal, okay, but whatever it is that you get for your Celsius measurement in lab, okay, that's the unit or the precision that you want to focus on, okay, so just make sure that you are paying attention to that little detail. Okay, so let's go ahead and let's practice. Okay, so basically I've been given 22.2 degrees C here, and they want me to convert to Kelvin. Okay, so we know that in order to go from Kelvin, or sorry, from degrees C to Kelvin, I need to add 273.15. Okay, so in this case, guys, in order to get my Celsius temperature into Kelvin, I need to take my 22.2, okay, plus 273.15. Plug that into your calculator, and that is going to give you 295.35. Okay, now one place to the right of the decimal is what I have from my Celsius temperature. Okay, so one place to the right of the decimal is what you're going to have here. So 295.4 Kelvin. Okay, so guys, notice I'm not saying degree Kelvin. I'm just saying Kelvin. That is the correct term. You should never, ever have a degree symbol next to the Kelvin unit, okay? All right, and if you guys want to, obviously, or need to go from Kelvin to Celsius, you're just going to subtract out that 273.15 and reverse the process. So this is, I feel like, a really straightforward conversion. This is the only conversion that I'm going to require you guys to know in this class with regards to temperature. If I needed you to convert between Fahrenheit or something of that sort, like Fahrenheit and Celsius, I would give you the equation for that. However, I will not be giving you the equation for these, or for this example, so you want to make sure that you're comfortable and memorize the conversion factor, which is 273.15.